Hi everyone, today we are going to do a practice problem on motion in a straight line under constant acceleration. So last time we already discussed the concept of this, but now we are going to do to answer a problem. Okay, so if you can remember, we need to keep in mind three equations when it comes to these kinds of problem. So first, of course, is the distance equation. That would be x equals x naught, or the initial position or distance, plus v naught, or the initial velocity, times t, plus 1/2 at squared. The a is the acceleration and t is the time. So second formula that we need to keep in mind is the velocity formula. So this is v, or the final velocity, is equal to initial velocity plus acceleration times time. And of course, the final formula that we have to remember is also a velocity formula, but using a different set of variables. So this is v squared equals v naught squared plus 2a times x, or the final position, minus x naught, or the initial position. So question, do we have to memorize all these equations? I'm sorry to break it to you, but yeah, we do have to memorize these equations. And yeah, as long as you keep answering or you keep practicing on a lot of problems, I think at some point you will just be able to memorize them. And yeah, the more important thing is, of course, to really understand these equations, like to know at which situations can we use a certain formula. Okay, so more in this later. We will discuss this along the way. Okay, so let's get to our problem. So our problem is, let me just read it. So a block slides along a frictionless surface with a constant acceleration of 2 meters per second squared. At time t equals 0 seconds, the block is at the distance 5 meters and traveling with a velocity of 3 meters per second. So there are 4 questions. So first question, where is the block at t equals 2 seconds? Second, what is the block's velocity at t equals 2 seconds? And third, where is the block when its velocity is 10 meters per second? D, how long did it take to get to this point? Okay, so there are a lot of questions. So we don't get overwhelmed. We need to draw the diagram first. It's always good to visualize word problems like this so that we can better understand the question. So let's go back from the start. It said a block slides along a frictionless surface. So take note, it's frictionless surface. What does that mean? There's no friction. There's no force that would slow the object down while it slides along the surface. Okay? So this is our surface, our frictionless surface, and this is our block. Okay? With a constant acceleration of 2 meters per second squared. At time t, equals 0 second, the block is at x equals 5 meters. So that means at the starting point, this point, so this would be t equals 0 seconds. The distance of this point from the origin is 5 meters. So this means that, for example, this is the origin. This is from this point to this point, it's 5 meters. Okay. Okay. And the time t equals 0, the block is at 5 meters. Okay, and traveling with a velocity of 3 meters per second. So at this time, it's traveling at a velocity of 3 meters per second. All right. So let's say the block slides along, to the right direction. To the right. Okay. So first question, where is the block at t 2 seconds? So let's just write all the questions, okay? So where is the block? So that would mean we're asking what the distance of the block from the origin at t equals 2 seconds. Second question, what is the block's velocity at 2 seconds? So v, we're asking v at 2 seconds. Third question, where is the block when its velocity is 10 meters per second? So x, of course, because where? We're asking about the distance. Where is the block when its velocity at v equals 10 meters per second? And finally, how long did it take to get to this point? So I think this point means this x that we're going to solve. So at this x, or at this position, what's the time? How long did it take for the block to get to this x from our third question? Okay, so just by looking at the questions, we know that we have the initial position, this one, and we have the second position. This is at the first position is at t equals 0 second, and the second position would be at after 2 seconds. Okay. Okay, so now that we know that, now that we have drawn the diagram, we can now visualize what's going on in our question, and it will be more organized. Okay, so as you can see, it would help if you first write all the equation that you think that can be used, and then we're going to draw the diagram, and of course we're going to write down each question in variable form so that it will be, easier to see. So, okay, so let's answer the first question. So where is the block at t equals 2 seconds? So first thing that you have to do is to inspect the three equations that are available for you to use. So we're being asked what's x, given that we have final t is 2 seconds. Okay? So first, we're going to inspect, which one of these three equations can I use? Can I use equation number 2? No, because we don't have a distance variable here in the second equation. Can I use equation number 1? Okay, we have the distance variable, x. We also know x naught, which is 5, okay? We also have information on the v naught, and the time, of course, we're given, and also the acceleration. So yeah, it's clear that we can use equation 1 for the first question. So we are just going to write the equation or the formula. So x, okay, so what's our x? So the x is actually what we're looking for. So we'll just write x, and x naught is, of course, the initial position, or the position at t equals 0 seconds. So this would be 5 meters. Our initial velocity would be 3 meters per second. So just put that times time, which is given 2 seconds, plus 1/2 times acceleration, which is also given 2 meters per second squared, times t, again 2 seconds squared. Let me know if I'm being too fast, okay? And if you have any questions, please don't hesitate to ask, because I can always repeat what I've just said. So after that, so I think we already substituted everything. So we're just going to calculate this. So x equals 5 plus 6 plus 1/2 times 2 times 2 squared is 4. Yeah, you can calculate that, and this will give you 15 meters. Don't forget the units. Never forget the units. Since it's distance, it should be in meters. So this is our answer to our first question. So it's pretty straightforward, right? And it's pretty easy. As long as you know which equation you can use, then it should be easy. Okay, our second question. So do you have any questions? Please, again, you can always raise your hand, or you can always unmute and ask me your question if there's any confusion. Okay? All right. So now we're going to proceed to our second question. What is the block's velocity at t equals 2 seconds? Okay. So this, in the looking at our diagram, this v equals 3 meters per second is actually our initial velocity at t equals 0 seconds. So we're being asked, at this position, and the second position, what's our velocity? Okay? So, yeah. Now we're going to look at the three equations, or the three formulas that we can use again, and determine which formula can we use for this problem. So we're being asked the velocity, right? So let's look at the first formula. Can we use the first formula for a second question? We're looking for the final velocity, since we already know the v naught, or the initial velocity. But we can see in our first equation that there is no variable of the final velocity. So no, we cannot use this formula. So moving on to the second equation, this v is the final. If there's no subscript, we should always assume that, oh, it's the final velocity, because we have v naught. We have the zero subscript for initial values. So v, okay. So this is, do we have the information of v naught? Yes, we have 3 meters per second. We also know the acceleration, which is 2 meters per square second. And t, we're also given 2 seconds. So we can use the second formula. So v equals v naught plus at. V naught is, again, our initial velocity, that would be 3, plus our acceleration. Oh, but then you might ask, oh, what is the acceleration? Isn't this the initial acceleration? No, because this is the acceleration for all positions, because we are dealing with constant acceleration here. It's a frictionless surface. So there would be no force that would slow down this acceleration, or that would change this acceleration. Okay. So 3 plus acceleration is 2. And then time is 2 seconds. So this would be 3 plus 4, 7. What's the unit for velocity? Of course, velocity is distance over time. So that would be meters per second. Okay. So this is the answer for our second question. Okay. So if you can see, again, for each question that we encounter, we look at our formulas first and determine which of the formulas we can use. So yeah, you can always use elimination method, or you can check each formula to see if that formula works. Okay. So third question, I'm just gonna write it here. Where is the block? What's the distance of the block from the origin when its velocity is 10 meters per second? So again, we're looking for x, and we are given v. We're given the final velocity here. Okay. So let's check which formula we can use. Okay. Can we use, let's see. Can we use first equation? Okay. Do you think we can use the first equation? No. Why? Because we are given the final velocity, which is 10 meters per second. But in the first formula, there's no variable of the final velocity, right? So we cannot use this value. So we cannot use the first formula. How about the second formula? So we have v, the final velocity variable here, and we also have v naught and acceleration and time. But then we are being asked, what's the distance? of the block at this certain velocity. We're looking for x, and the second formula does not have an x variable, so we cannot use this. And yeah, so we cannot use the first two equations. So looking at the third equation, okay, we have final velocity, we also have initial velocity, we also know our acceleration, and of course, the most important, we have the x variable, or the final position or final distance variable x, and of course the initial position. So we can use this third formula. So v squared equals v naught squared plus 2a times x minus x naught. So our final velocity, it's given in the question, it's 10. 10 squared equals, what's our initial velocity? It's here, 3 meters per second. So 3 squared plus 2a, what's a? A is constant again, it's 2. So just put 2 times x. So this is what we're looking for. So let's just leave it as is, minus x naught, which is the initial position. X equals 5. X naught equals 5. So just solve the equation so you can get to your x. So this is 4x minus 5. 100 equals 9 plus 4x. You're going to distribute this 4 minus 20. So I'm going to move everything here. 100 minus 9 plus 20 equals 4x. So 4x equals 100 minus 9 is 91 plus, sorry, this should be plus 20 is 111, right? So x, divide 111 by 4, that would be 27.75 meters. Okay, so this is the answer. So at velocity is equal to 10 meters per second, the block should be at x equals 27.75 meters. Okay, so any questions? All right, again, if you have any questions, please, and you can unmute or you can raise your hand. You can call out anytime, okay? Okay, so now we can proceed to our last question, but I don't have space anymore, so I'm just gonna erase this part, the first two questions. I hope you've taken notes. Yeah, please take notes. Please always take notes because it's a good practice. So if you have to review, you have something to look at. Okay. So let me just erase this real quick. Okay, it's taking a while to erase this. Please wait. So what's our biggest takeaway from this lesson or this problem solving part so far? So our biggest takeaway is that you should really understand each formula that we're dealing with, because we can memorize all these formulas, but if we don't know how to properly use them, then we'll have a hard time identifying which formula is best in solving a certain problem. Okay? So now let's proceed to the final question. Letter D, how long did it take to get to this point X from the previous problem? So how long did it take to get to 27.75 meter mark? Okay. So I'll just put here so we'll remember 27.75 meters. We're asking for T. Okay. So actually for the fourth question is related to the third question. So just to make sure, if these related questions come up, you should always double check your previous question if you actually did the solving part correctly, because if you're gonna mess up in the previous question, then you will also mess up in the next question. Okay, so all right, so again, we're going to look at our three available formulas and determine which formula is best to solve this problem. So let's check first. So let's look at the first equation first. So we're looking for t. So okay, this formula has the variable t, and we also have information on the x naught, the initial velocity, okay, and we also know the acceleration because it's constant, and of course the time. We are looking for the time. So yeah, we can definitely solve using this first equation. But then we can also look at other equations, okay? So let's see first the second equation. So second equation, it doesn't have again the x or the distance variable, but then it's part of the given, so we cannot use this. But for the, oh, let me see. Actually, the second equation we can actually use since we're looking for the time only. And even if we cannot use the x equals 27.75 meters, we know that this distance, the at this distance, the velocity is 10 meter per second from the previous question, right? So for if we are going to use the second formula, we already know the final velocity, which is this 10 meter per second. The initial velocity, we also have data on that, 3 meters per second. We also know our acceleration. Okay? So yeah, so this could be a lesson. We don't always have to use the given that we're the data that we're given, as long as we have all the data for the variables in that equation. So in this case, we know the v, or the v at this position, at this x equals 27.75. So we can actually use the second formula. So okay, let me try. Plus 80. So again, at x equals 27.75 meters, although this is not explicit, like you just know that this is at this distance, we know that the velocity is 10 meters per second. V naught is 3 plus acceleration is 2 times time is, yeah, we're being asked for the time. So 3 plus 2t, 7 equals 2t. So time is actually 3.5 seconds. Okay? Yeah. And just to check, if you want to check, you can also solve using the first equation. You can always do that if you have the time. So you know x is 27.75, right? And x naught is, again, 5 meters. Plus v naught is 3 times time. That's what we're looking for. Plus 1/2. Wait, let me just erase this part. Oh, it's not. Anyway, it's not. Okay. The eraser is kind of delayed, so sorry about that. Okay. Let me just erase this. Okay. So 1/2 times acceleration, which is, again, 2 times t squared. So we're looking for t squared. Yeah, this first formula is kind of long. So if you don't have a lot of time left, you should quickly discern, oh, among all the equations that I can use, which is shorter, which is easier to use. And then you should use that equation. Okay, so 27.75 equals 5 plus 3t plus 1/2 times 2 is just 1. So this will be t squared. So that's it. So you're gonna transfer that. So see, like 27.75 minus 5 is 22.75. So you're actually left with a quadratic equation, which makes your life a little bit more difficult. Okay? So you can also use this and you arrive to this one and you'll have to use your calculator if you're allowed to, but ultimately you're going to arrive to this answer, which is 3.55 seconds. Okay? You can substitute this 3.55 seconds to this formula, to this equation, and then you'll see that it will um it will be correct. So yeah, so there are some times that you can use multiple equations, but then yeah, you can use multiple equations to solve a problem, but of course you should always try to save your time because this is not the only problem that you're going to solve. So quickly check all the three formulas and see which ones you can use. And if you have two available options, you should choose the one that's easier to solve. Yeah. In this case, this second equation, we should use this one instead of the first one because the first one we will arrive to a quadratic equation, which is more complicated. Okay, so we have answered all our four questions for this problem. I hope everything is clear, and I hope now you understand more how to use or which formula is the best to use in certain types of question. So again, it's really good if you visualize the problem first, and then you write all the questions down, and then you define all your variables. You should know which variable is an initial, for example, initial variable and the final variable. For example, you should know which one is the initial velocity and the final velocity. Okay, so in order to do that, drawing the situation helps a lot. Okay, so if you have any questions, please feel free to ask. And if you don't, let's take a quick break. Thank you.